Okay, so in the last video, we had found out maximum negative shear force at C and maximum positive shear force at C. The problem was this, where you had a, 40 kilonewton per meter UDL, smaller than the span, 5 meters uh, length of load, which is passing over a span AB, okay, which is 15 meters in span. So you have already found out the ILD ordinates and then calculated what is the negative shear force and a positive shear force. Now these were found at a section C. Okay, because that was asked in the question. Now, the next thing is you have to find out what is the bending moment at that section. So, maximum bending moment at that section. So, as you can see in the figure, ILD for bending moment at C is also shown, and the maximum ordinate is Z into L minus Z by L. So, our first step is to find the ILD for moment at C is drawn. Okay. Now referring to that figure, you have YC is equal to Z into L minus Z by L. What was Z? Z was located at a distance. I mean, Z is given as 6. 6 into 15 minus 6 divided by 15. So the answer we will get is 3.6. So the ordinate, maximum ordinate under moment is 3.6. Okay. Okay. Next, what we are going to do is you have got the ordinate. Now you have to calculate what is the bending moment. So how do you find out whether bending moment, where it is maximum, that is at a section, bending moment at a section is maximum when you have a condition, no, when the load is so placed that the section divides the load in the same ratio as it divides the span. What was the equation you have derived? X by d should be equal to Z by L. So I'll just write that again. Bending moment at a section, bending moment at a section is maximum, okay, when the load is so placed that the section divides the load, when the section divides the load in the same ratio as it divides the span. Okay, for example, you have to write all this. Okay, so that means X by D is equal to Z by L. Okay, so you have to find out what is X by D. I mean, what is the position X, how you have to position your load. So X by D is 5 meters was the length of the UDL, is equal to 6 by 15. From this you get X as 2. Okay, so and also using similar triangles, just like how we found out the ordinates, because you need the area under the ILD. So using similar triangles, so I'm just going to draw the figure and how your load is placed. If you have space here, you can draw it directly here. So I'm drawing it as a separate picture here. Okay, so because it's I have to keep scrolling up all the time. So this was the ILD which we had drawn. This is section C, this is A and B. Now you have to position your load such that, so we know that AC is 6 meters and CB is 9 meters, right? So your total length of load is 5 meters. You have just now found that you have to place your load 2 meters, that is X is 2. So that X we had shown in the derivation, it is 2 to the left of C. So this is 2 meter means to the right of C it is 3 meters. So this is how you will place the load. Okay, so accordingly, this is the maximum ordinate YC. Now this will have one ordinate here, and this head of the load will have another ordinate here. So I'll call this as Y1 and this as Y2. Okay, you have to calculate what is the area under this whole figure and then multiply it with the UDL density. Okay, So um, this is 2 meters means the rest of this is 4 meters. This is 3 meters means this much is 6 meters. So using similar triangles, you can write y1 by yc is equal to 4 divided by 6, right? So from this, I'll get y1 as yc is already found out as 3.6. So y1 you will get as 2.4. Similarly, y2 by yc is equal to 6 divided by 9. From this, y2 is also obtained as 2.4. Okay. So therefore, now you can find the maximum moment at section C. At section C is equal to load intensity into area of the ILD. So that is equal to 40 into, we'll take this trapezoid first and then the other trapezoid. So 40 into 2.4 plus 3.6 divided by 2 into 2 meters plus 40 into 3.6 plus 2.4 divided by 2 into 3 meters. Okay, this will give you the answer as 600 kilonewton meter. Okay, so that was the maximum bending moment at C. Okay, so this is how the problems will be asked. That is how to solve it. I hope it's clear. So you will start with the figure, and then you have to find you have to find the ordinates and then use those diagrams, and you also should remember the equation at which you have to place the load so that you can find out what is the maximum bending moment. Okay, so in the next video, we will see how to analyze a beam when there is a train of concentrated loads. That is the last part of the syllabus. After which we will do some more problems.